All right, Emerald, I'm talking to you. I'm talking to Sydney, Isaiah, Jessica, Ruger, Logan, Josh, and Tristan. All right, I'm talking to all you because I'm going to be taking my mother-in-law to the airport during that period today, and I'm not going to see you till this afternoon when I give you your papers, all right? But the paper I want to give you is the worksheet from yesterday. So I'm going to give that to you in just a minute, all right? I'm going to share that screen. All right, I realized I was muted. Okay, so I won't see you today. I'm going to be taking my mother-in-law to the airport. She's going off to California, and I will be joining her on Friday. But wanted to make sure you guys got the information before I did for the Kahoot this week. All right. So the first thing I'm going to do is give you the answers. My dog wants to play, and I give you the answers for this week's worksheet. So you have the worksheet in front of you. Fiore's, do what you started on Monday, finish off what you started on Monday, all right? And then you guys will have your own separate Kahoot. Anyway, the rest of you, here we go, all right? You have the worksheet in front of you? Here we go. Air pressure determines wind and weather patterns. Blank causes the atmosphere to push against everything it surrounds. Something causes the atmosphere to push against everything it surrounds. What is that? Let's take a look. I want to show you that a little bit later, but let's see. This is called the Java Lab. It's pretty cool. Now this is a simulation of what the atmosphere is like, right? So here you have the troposphere, right? All of the things that exist inside the troposphere. But one thing I want you to notice is here on the left, you've got all these air molecules. Those are representative of air molecules, and there sure are a lot of them. There's a big amount of them right here at this line. Look at this line right here on the right. You see how it's at the bottom of the mountains? It's right at the top of the sea. You call it sea level. It's right at the top of the ocean, right? Now look what happens when I drag this slider up. Look what happens to the molecules on the left. Can you already see it happening? There we're just about at the top of the mountains now. There's a lot less of them, right? And I go all the way up here to the troposphere. There's very, very few, right? Which makes it difficult to breathe. That's why jet fighters and people like that bring their own oxygen with them when they're in the plane. But look, now we come down here to sea level again, and those molecules increase. But the question is, what is holding them to the planet? You guys already know the answer to this one. What is holding them to the planet? That's right. You see it? It is gravity. Exactly right. Gravity causes the atmosphere to push against everything it surrounds. And so, and we'll get into that when we talk about the barometers a little bit later, because this is about air pressure and about barometers. That's what it is, air pressure 1. All right, now listen to this. Air pressure is the blank per blank of area exerted on the Earth's surface by the blank of the air above the surface. There's 3 of them on this one. Okay, but there's only 8 questions, so it's very easy. All right, air pressure is it's connected to gravity. And what is gravity? Gravity is a force. Exactly right. Force per unit. Unit is how you measure things. So, for instance, if you have a square foot sitting on the ground, the gravity pushes the air down onto that square foot, and the air pressure is the force that the air exerts on that surface of square foot. by the blank of the air above the surface. So it's related to gravity. So what do you think it is? You have the same thing. When you measure how much gravity is pulling on you, you call it something that starts with a W. Right. Wait. Good job, guys. I knew you were quick at it. All right. As the blank of molecules increases, amount of molecules increases, they push more on a surface, and the total atmospheric pressure does the same thing. It increases. Amount is AMOUNT, increases INCREASES. Take your time, Josh. You're good, man. All right. Here we go. So if the number of molecules does this, what's the opposite of increase? That's right. Decrease. You got it. So if the number of molecules decreases, decrease, increase, crease. What is that? Crease. What a crease is? Like you have a pair of pants and you have that line down the front of the pair of pants where the fold is. They call that a crease. Interesting. All right. Air pressure is measured with blank or blank barometers. What's the first one? The first one has to do with that white silvery metal, atomic number 80, Hg, mercury. Good job. Or what's the other one? The other one that doesn't use mercury, it uses that coil, that diaphragm. Remember? What do you call that one? Remember? Aneroid. Good. Mercury or aneroid barometers. All right. Mercury barometers measure the blank of a mercury blank in a vertical glass tube. Let me remind you what that is. All right. Let me go here to atmosphere. I love these are great little apps. But look, Torricelli's experiment. Torricelli is the Italian scientist who figured this out. That he could use a reservoir of Hg, the silvery white metal, mercury, right? And put this glass tube in it. And when he did that, the air pressure would push down on that mercury, sending it up in a column inside that vertical glass tube. Now, the thing about the vertical glass tube is the air pressure at sea level rises that mercury level to 760 millimeters up the glass tube, up the gradated glass tube. So I'll write that down because you'll need to know it for a little bit later. 760 millimeters. 760 millimeters. There you go. All right. But that's not what I wanted to, that's not even what I was trying to say. Okay, let me erase that. 760 millimeters. Remember it though. Now look here. Here I can tell it to show me what the pressure is on Earth, on the moon, on Venus, on Mars. Look at on the moon, for instance, no air pressure at all. So no column goes up into that tube, right? 0 atmospheres. On Venus, it's around 90 atmospheres, so the tube is completely full, right? The air pressure is much higher. We have 1, Venus has 90, right? Air pressure, that much more air molecules, and plus the planet is bigger, there's more gravity because the planet is bigger. Therefore, more of the air, such as it is, you can't breathe it. I wouldn't even call it air. The atmosphere pushes down and then sends the mercury all the way up. And in Mars, not even enough to register here, right? 0.006 atmospheres. So, excuse Excuse me, guys, getting late. All right. So that's what I wanted to show you. But what I wanted to do is this one. Okay. Mercury barometers measure the height of a mercury. What did I say it was? In a vertical glass tube. Just like basalt is formed in a column, right? Column. Vertical glass tube. As air pressure changes, the height of the mercury column does too, just like just like the thing you measure temperature with. What do you measure temperature with? Right. Thermometer. Thermometer, right? Thermometer. All right. Meteorologists, people that study the weather, measure air pressure in units called atmospheres, which we saw in the Java lab. 1 atmosphere is equal to this many millibars. Watch, 1,013. Let me do it like that. 1,013 millibars, which translates into how many millimeters of quicksilver, which is the same as mercury, when measured on a mercury barometer. Anybody remember? We just did it. 760. Good job. Okay. All right, here we go. An aneroid barometer, which is what most wall barometers are, uses a blank of tubing. You see the way it's shaped? Look, let's go down here to the extra credit. You see the way that's shaped? It's shaped like a snail, just like the cochlea inside your ear. For those of you that remember, look at the cochlea. Remember this purple thing here? It's not really purple, but they do it to show you the difference. Cochlea. I wonder if I can show you on the anatomy. Yeah, break out my anatomy book here. The brain, nervous system. Let's see, I better look at the index for this. Skeletal system, respiratory, digestive, cardiovascular, lymphatic, nervous, hearing. Okay, cochlea 483. Here we go. It's going to be kind of gross maybe for some of you because they actually use cadavers to, in some cases, to show these things like dead bodies. No, but down here. Not here. Okay. All right, here we go. The cochlea. All right. Kind of shaped the same way. That's all I wanted to say. Shaped the same way. But that shape is called a coil. 4 letters, C-O-I-L. Coil of tubing with most of the air removed. What do you call it when you remove most of the air? You make a vacuum, you're evacuating it. Good. The coil bends inward when the pressure rises, right? Pressure pushes down on it. There's nothing inside of it. Therefore, it bends. So bends is B-E-N-D-S. When the pressure rises, and the opposite word they're going to tell you of bends in, bows out. Bows out when the pressure drops. Okay, good. Okay, for extra credit, what I want you guys to label is the pointer and the coil. Just showed you where the coil is. Pointer, coil. Put them in the right box. There's only 2 boxes. 50 points per label. That's 100 points. Easy 100 points. All right. Nice job, you guys. Thanks for bearing with me. And let's see, I'll stop to share the screen, and I'll see you guys later this afternoon.